So here's this type of problem. Some people will say you should kind of see how to do this right away, but I think that's pretty tough. I'm not really about that. So I'm going to use the Richmond method to factor this, just like I always would. So how do we do that again? We take this 9 and we multiply it by the back number. So that gets us x squared minus 6x plus 9. And then we can just factor that. So that's going to be x minus 3 times x minus 3. So now you see it's a perfect square. That's kind of why this problem is interesting. But we'll just continue. So the next step in the Richmond method is you divide both of these numbers by the a coefficient, which is 9 in this case. And then we got to simplify those fractions. So that's 1/3. And then the last step of the Richmond method, slide it to the front. So 3x minus 1 and 3x minus 1 equals 0. And so we can do the same type of thing here. But I think what they're getting at with this example is they want us to write it like this. 3x minus 1 squared equals 0. Because now, how do you get rid of the squared? Well, you always do the same thing to both sides. So you can square root both sides. You get 3x minus 1 equals 0. And so x is just 1/3. And notice how I said with a quadratic last time that we expect 2 solutions with a quadratic. But here we only got 1. And that's true, that does happen sometimes. But that's kind of because what actually happened is, look at right here. It's like we did get 2 solutions. They're just the same solution. So we actually have a name for that. We call that a double root. And I usually mark that with a little dr there. But that's how you solve this. You just factor it, just like all other quadratics.